Hello everyone, I'm Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will talk about Barton Decarboxylation reaction. In Barton Decarboxylation reaction, carboxylic acid or acid halide are the starting material. When carboxylic acid or acid halide react with N-hydroxypyridine or pyrithione, it produced Barton ester. And then this Barton ester react with catalyst. Which type of catalyst? Tributyl tenhydride or tertiary thiol. When this Barton ester react with such type of catalyst, it resulted in the formation of alkane. And this reaction carried out through a radical mechanism, or this reaction involves radical chemistry. So how radical chemistry involved in such type of reaction? We will see it in the reaction mechanism. So what is the reaction mechanism for such type of reaction? By homolytic cleavage of 2,2' as a bis isobutyronitrol. This is the structure of 2,2' as a bis isobutyronitrol. When this is homolytically cleaved, it resulted in the formation of tertiary radical with the evolution of nitrogen gas. As we already know that in the homolytic cleavage, let's suppose this is the bond between carbon and carbon, and sigma bond is formed of two electrons, so one electron and second electron. So as the result of homolytic cleavage, homo means same, so if the bond is formed by sharing of two electrons, so one of the electron will be moved on one carbon atom and another electron will be moved on another carbon atom. This is because of the homolytic cleavage. So the net species will be carbon radical plus carbon radical. So same is the case with this species as a bis isobutyronitrol. In this case, the bond is in between carbon and nitrogen, so by homolytic cleavage one of the electron will be shifting on nitrogen atom and another one is on carbon atom. So here the structure is this radical and nitrogen gas. Then this radical will take part in the propagation of reaction. How? Like this. When this radical interact with tributyl tenhydride, it causes the homolytic cleavage also in this reaction. So how homolytic cleavage will take place in this reaction? As we discussed in the previous slide, that when in case of homolytic cleavage, one of the bonding electron will be moved on one species and another electron will be moved on another species. So same is the case in this reaction. So if we talk about tenhydride, it is also made up of two electrons, so one electron will be moved on 10 and another towards hydrogen atom, and when hydrogen radical is formed, then this hydrogen radical will interact with this another alkyl radical and it will be converted into this with the generation of 10 radical. Then this 10 radical will take part in the reaction. As we talk about that in this type of reaction Barton ester is produced, so this is the structure of Barton ester. Then this 10 radical will interact with this Barton ester. How? Let's have a look to this Barton ester. So if this is the thione structure and it is 10 radical, so one of the bond is sigma bond and another is pi bond. So pi bond is also made up of two electrons, so one electron will be moved on this carbon atom and another toward sulfur, so it will then form bond with 10 like this, and this is radical. So if we talk about this structure, so how it is possible in this type of structure? Sulfur with 10, so here radical on the carbon atom just like this one, and here nitrogen is present, so nitrogen bond with oxygen, and here carboxylate group. Here the bond between nitrogen and this bond. The bond between nitrogen and oxygen of carboxylate group. This bond is not too strong, so it will also cleave homolytically. So it is made up of two electrons, so one bond will move here and the carbon radical should head their electron toward this bond, and another electron will be moved on this oxygen atom. And what will happen? This carboxylate radical. So if we talk about this, it is the carboxylate radical, and this pyridine structure is produced in here. So this carboxylate radical is highly unstable species. So how it will be converted into the next product? Here the bond will be cleaved homolytically, and it will evolve carbon dioxide gas, and alkyl radical will be generated. So now this alkyl radical will abstract a hydrogen atom from tributyl tenhydride, and as a result alkane will be produced, and another species is 10 radical. As we already discussed that this 10 radical is produced by reacting tin hydride with this type of radical and this structure. So if we talk about this, let's suppose this is structure A and it is also structure A. Compare these two structure, both are same. So here this radical is regenerated. So this is the catalyst activity of catalyst, that it take part in the reaction, and in the end of reaction this catalytically active species is regenerated. So this 10 radical is regenerated with the production of alkane. So this is all about Barton decarboxylation reaction, in which carboxylic acid or acid halide are converted into alkane with the regeneration of this 10 radical species. I hope you enjoyed the videos, and if you have any type of question you may ask in the comment section. Thank you so much. The Allah Paman.